Hello students, in today's topic we'll be discussing measurement of temperature. Now first of all, what's the definition of an atmospheric temperature? The thermodynamic temperature is defined as one of the 7 quantities in the SI unit. The definition of the temperature is as below. The Kelvin, that is the unit of a thermodynamic temperature, is the fraction that is 1 by 273.16 of a thermodynamic temperature of a triple point of a water. Now what is the triple point of water? Triple point of water is the temperature where the solid, liquid and the gaseous phase of a temperature coexist simultaneously, which is basically 273.16 degree, that Kelvin, or it's also known as 0.01 degree Celsius. Now the first international temperature scale was established in 1927, which is shown on this figure. Now since that it has been revised several times to expand the temperature range and to improve the accuracy. Currently the international temperature scale of 1990 is in effect. The ITS 90 defines the fixed points of temperature, the type of instrument along with the method to interpolate in between fixed points of the temperature. Now the principle of the instrument which is measuring the temperature, there are many different types of thermometers. The major one employs the characteristics of basically the expansion and the contraction of the substance according to the temperature, employs the valuability of the electrical characteristics of a substance according to temperature, or employ the characteristics between the temperature and the heat radiation energy emitted from the surface of the substance. Now the first category which is used to measure the temperature is electrical thermometers. Now electrical thermometer includes an electric resistance thermometer, a semiconductor thermometer, that is thermistor, or a thermocouple thermometer. Now platinum resistance thermometer is explained as a representative of the electrical thermometer in this section. Now platinum resistance thermometer employs a platinum characteristics which changes resistance according to the temperature. Now it allows us to obtain the temperature by measuring the electric resistance. High purity platinum is used since the containment of the platinum is greatly affects the resistance. Now the sensor for meteorological observation is made with a thin sheet of mica or a porcelain wrapped around this platinum wire, and it's placed in a stainless steel protective tube which has excellent thermal conductivity and corrosion resistant that made it to completely waterproof. Then the next class of thermometers is the liquid in glass thermometers. Now the liquid in glass thermometers basically measure temperature based upon the expansion of mercury or the spirit alcohol in a glass container. The boiling point of mercury is 356 degrees Celsius and the melting point is minus 38 degrees Celsius. Now the boiling point of methyl alcohol is 64 and the melting is 97 degrees Celsius. So because mercury has the low thermal capacity, high thermal conductivity, inertness in relation to the capillary of the tube and high boiling point, it's the ideal liquid which can be used for its relatively high because of its high relatively melting point. Now according to mercury thermometer are used for ordinary meteorological observations, and spirit thermometers are used for involving temperature below the melting point of mercury, because we clearly see the melting point of the spirit is minus 97, which is way below than the melting point of the mercury. Now glass and liquid consist of a capillary tube with a bulb at the one end and filled with the thermometric liquid, which is vacuumed and sealed. By reading the position of the liquid level on the scale, the temperature value can be obtained. Now designs can be classified either as the shelf type or the unshelf type. A shelf type thermometer consists of a bulb, a slender capillary tube consisting connected to it, a milky white scale plated attached to the capillary, and an outer glass bulb encloses them. A shelf type thermometer consists of a thick walled capillary glass tube and a scale marked directly on it. Now the advantage of glass liquid thermometers are there because their design is simple observation method and a possibility of temperature measurement anywhere as they require no electrical power for the operation. The disadvantage is the handling is required because the glass material is quite fragile. The next type of measuring instruments are your bimetallic thermographs. They consist of bimetal and a clock driven drum on which a recording chart is mounted as shown in this figure. The curvature of the bimetallic strip changes with the response to temperature variation, and this curvature records that change. The bimetallic consists of two metal plates with different expansion coefficient welded or braced and then rolled in an appropriate thickness. Now, as the temperature changes, the bimetal curves due to the difference in the expansion coefficient of the metal, it changes. So this change is mechanically magnified and then recorded. In this figure, we can see the bimetallic thermographs. Now, the working of the bimetallic thermographs is as follows. The structure is shown in this figure. Now, when the bimetal curve is response to temperature change, the bimeter level changes, which is attached at the end of this metal strip. Now, the motion is transmitted magnified using adjustment lever via steel strip, which moves the pen arm attached to its magnification adjustment lever. In this way, the temperature changes causing the bimetal to curve to record on the chart and the clock driven drum with the pen tip at the end of this pen arm. Now, the advantage of bimetal strip, that is chart can be charted over a certain period of where no electrical power is available. The only disadvantage is the accuracy of these bimetallic strips is quite less in comparison to liquid in glass or electric thermometers. Its mechanism does not allow continuous reading over a longer period of time, and remote sensing is also not possible in bimetallic strips. Thermocouples. Now, thermocouples comes in a wide variety of material. Each material pair has a different characteristics of temperature range and voltage. The voltage produced by the thermocouple is quite small and in millivolt range, and it's non-linear in nature. Deriving the temperature from the voltage produces require the output to be matched with the Lucas table and fed up through the polynomial curve to return the actual reading. Now, the table over here shows the thermocouple sets and their basic parameters. Like there are different type of thermocouples like type J, K, T, E, N, S, B, C. They are the materials. Their minimum maximum temperature is also given, and minimum and maximum, correspondingly voltage range is given. Now, the first three in this are commonly used throughout the industry, that is type C, type J, type K, and type K. Type J has been predominant over a certain period of time. Now, this has been recently replaced by type T and type K thermocouples due to the maintenance issue of type J. Iron thermocouples and iron connections are because they are being connected using iron connection which corrodes. So, the maintenance of type J is quite poor. So, these are certain set of instruments which can be used to measure the temperature. Thank you.